Section 5 of the Harmonized National Research and Development Agenda covers disaster risk reduction and climate change initiatives that address the Filipino aspirations of safe, inclusive, resilient, and sustainable communities. The DOST plays a major role in the Philippine disaster risk reduction and management for the DRRM system. Recognizing the magnitude of and an urgency to fulfill this responsibility, in 2017, the DOST created an office headed by an undersecretary that will focus on this particular societal need. I was appointed to be that undersecretary. In contrast to the other agenda of the NRDA, which are managed by sectoral councils, an advisory body under the DOST system, the DRRCC agenda is managed by the DOST Central Office. The NRDA is a national policy. It is fed by evidence. It reflects the values and mandates of DOST and other research institutions, and it recognizes political realities and governance structures. The DRRCC agenda's desired outcome is science, technology, and innovation for safer communities. The goals and objectives of the DRRCC agenda are primarily derived from the national policies and plans of the Philippine Disaster Risk Reduction and Management System and the National Climate Action. Internationally, the DOST is a very active stakeholder and lends key resource persons to the global platform on disaster risk reduction, as well to its biannual report, the Global Assessment Report, and to other regional counterparts of the global platform. Therefore, at the operational level, the goals and objectives of the DRRCC agenda respond to the national and local aspirations. They also align with international agreements, giving it a global and strategic perspective. The DRRCC agenda identifies 8 key result areas grouped under 3 strategic concerns, namely 1. Knowing the disaster risks, 2. Communicating the disaster risks, and 3. Investing in developing SDI solutions to address preventable disasters. Strategic Concern 1 is primarily about developing systems to monitor known and most frequently encountered natural hazards and developing technologies and models to improve the forecasting capabilities, especially timelines and accuracy of warning messages. Strategic Concern number 2 deals with communicating the hazards and risks, where they are expected, how big is the area and magnitude of impact, and what are the losses associated when these hazards would occur. It also aims to develop different communication platforms and materials, including those intended for decision makers to contribute to conversations in the policy arena. Strategic Concern number 3 focuses on developing technologies and applications for disaster and climate risk management to address preventable disasters. For 2018 to 2019, the DRRCC includes 34 projects spanning across nearly all the key result areas. Moreover, some projects deliver results that correspond to 2 or 3 key results areas. So in terms of results, there are more than the 34 formal project titles. The largest number of results, which nearly around 80%, correspond to 1 key result area in each of the strategic concerns. For Strategic Concern 1, the largest proportion of results come from KRA3, that is, Modeling and Simulation for Improvement of Monitoring and Forecasting. For Strategic Concern number 2, the largest proportion of results come from KRA4, Hazards, Vulnerability, and Risk Assessment. For Strategic Concern number 3, the combined development of science, technology, and innovation solutions for disaster risk management and climate change adaptation and mitigation are nearly the same proportion as those from the 2 other strategic concerns. Under Investing in Development science, technology, and innovation solutions to address preventable disasters, technology solutions, key result areas 6 and 7, technology development and application for DRM and climate change adaptation and mitigation. Majority of the projects are studies about various aspects of natural hazards, early warning systems, and disaster risk assessment. Understandably so, because this particular theme is the core service of two of DOST's attached agencies, PAG-ASA and PHIVOLCS, and hence have well-established research and development tracks. But there is also emerging interest in post-disaster information, and this is exemplified by the development of Disaster Loss and Damage Registry, and this is an emerging global movement. The use of space-based systems, or satellites, are being tested for various purposes: mapping pollution patterns, urban heat patterns, flooding and landslides, maritime surveillance, and planting activities, to name a few. Some of these results are valuable inputs to understanding climate change drivers, and they can help refine site-specific climate projections. There is also a continuing program of developing and deploying our own microsatellites. Here, we see the development of a technology and monitoring type studies feeding into each other and propelling their continuity. For the past few years, various provinces in the Philippines experienced water shortage, especially from prolonged dry spell accompanying El Niño events. Studies on water supply includes hydrologic modeling for impounded water in dams and groundwater. Another water-related study is the development of an autonomous underwater vehicle for environmental real-time monitoring. The results of these studies are much needed inputs to water management and prevention of water crises. Lastly, for urban areas, there is a study on fire hazard and fire spread modeling. One area that receives less attention than other KRAs is KR88 policy research. This is understandable because policy research straddles a point between science and social science research. Proposals of this kind can be submitted to DOST's National Science Research Council. Having said that, under this KRA, we would like to see two things. The first is to receive project proposals that assess the effectiveness of our DRRCC R&D results and which can be a basis for advocating a policy for wider implementation, so-called evaluation type researches. The second is to receive project proposals to study policies that impact disaster and climate resilience. For example, land use policy vis-a-vis decongesting Metro Manila as an approach for disaster risk reduction and management. This can also include more groundwater policies, governance structures, and dynamics that can be used as inputs to the creation of the Department of Disaster Resilience, and policy on hazard and risk-sensitive infrastructure and public structures vis-a-vis climate change and the consequence of altering the natural environment. Disasters and climate change are preventable. This is the whole message of disaster risk reduction, climate change adaptation, and mitigation. We conduct research and development to make science-informed decisions. But while we say science-informed, this is not a bias for researchers with advanced science degrees. Disaster and climate studies benefit from multidisciplinary, interdisciplinary, and transdisciplinary community of workers. And this is the one sure way for this branch of research to thrive. We therefore look forward to seeing researchers from various disciplines becoming part of the NRDA disaster risk reduction climate change agenda.